Hey folks, this second part of 2.1 is about forces and types of forces and free body diagrams. We're going to get right to it so that you don't have to look at the light behind me reflect off my head. Okay, so we're going to define a force. And so a force is just a push or a pull. And so mass is just this like property that objects have, whereas a force is an action on an object. Now, because it's a push or a pull, it is a vector. So the direction really matters, and it will be hard to forget that force is a vector. The unit for force is the Newton. There are many units that we'll learn about that are named after physicists. And so the Newton's the first one. The abbreviation is a capital N. Now, Newton is a derived unit, meaning it takes really simple things that we measure, mass, position, and time, and combines them, and this Newton is really just a shorthand for those units. So 1 Newton is the same thing as 1 kilogram meter per second squared. And so that's the unit Newton is mass times length divided by time squared. And maybe you can see something about forces just based on those units. Maybe not. Okay, so what follows is an introduction to all of the types of forces. Now, in the world of physics, there are only, I think at this point, 2 official forces, the strong nuclear force and the electroweak force. I'm going to go through a little prior history of forces just to frame this course and another course in high school you might take. Gravity is a fundamental force. That is a pull between all objects that have mass. We study gravity a lot in this course. That's the only fundamental force that we study in this course. Electromagnetic force is a push or a pull between objects that have charge based on what those charge objects are doing. Electromagnetic force plays a lot of roles in this video, but we don't actually study that force. You studied it a little bit when you learned about chemistry, the interactions of protons and electrons, but that's about it. The weak and the strong are both nuclear forces, and so they do kind of 2 different things. The weak nuclear force is something that kind of governs radioactivity. And the strong nuclear force is really like a binding force that holds the nucleus together. And so I don't know if you were in chemistry thinking like, okay, a helium atom is made of 2 protons and 2 neutrons. Protons repel one another, so what's holding them all together? And the strong nuclear force is the answer. Okay, so we're never really going to talk about all those forces again. We're going to talk about the contact forces, so gravity and the contact forces. What that really means is the force of gravity plus all of the forces that are consequences of the electromagnetic force. So I'll explain some of them briefly, but we'll write down some facts about them. This is a big information dump. The purpose of this section is just to learn the symbols and the rules for all the forces. So gravity is the first type of force. Its symbol is F sub g. That's a capital F for force, and then a subscript of a lowercase g. Now, gravity is responsible for an object's weight. And so in our textbook or in a random problem or thing that you're reading, you might see the force of gravity as a W for weight. The rule for gravity on Earth is that it's always down. Now, we will expand the definition of gravity when we start to talk about gravity in the universe at large, but when we're on Earth, gravity is always down, and the magnitude, meaning the number of newtons, that is the force of gravity, is always equal on Earth to mg. So the force of gravity on an object that's on Earth's surface is equal to the object's mass times the object's acceleration due to gravity, which is 9.8. We will talk more about mg later, but this is a really important equation and one that you're going to forget over the course of like the next day and a half, and then all of a sudden we're going to use it all the time, and you'll remember. Next up, we have the normal force. The normal force has a symbol of F sub n. The normal force is sometimes given the name of apparent weight. Apparent weight. And so the normal force is often how heavy you feel when your body's doing different things, like going on a roller coaster or taking an elevator ride. The normal force is one of two forces that is a surface force, meaning it is caused by an interaction between a surface and an object. The rule for the normal force is it's always perpendicular to and away from the surface. So the word normal in math is a word that means perpendicular to a plane. And so the surface is the plane. And if you put an object on the surface will push back on it. Again, these are going to be all consequences of the electromagnetic force. So when you put an object down on a table, the weight of that object strains the bonds between whatever atoms and molecules are making up that surface. When those bonds get strained, they push back, and that electromagnetic push back is what we experience as the normal force. So it supports us because of our own weight. Okay, friction is up next. Now, F sub F is a very common symbol, but very quickly, once we learn about friction, we are just going to use a lowercase f for friction. Now, there's a reason for that, and it has to do with the fact that there's two types of friction, but we'll get to that later. So friction is also a surface force, and it's a surface force that functions to prevent sliding. The rules for friction is that it's always perpendicular to the surface, and that it functions to reduce sliding. So when two objects are sliding together, they experience a friction force on one another. We will dive into where that friction force comes from, but it again has to do with the interaction between atoms on a really small scale. So it's again an electrostatic, electromagnetic force consequence. And so like if objects aren't sliding, but they could, then there's a friction force. And if objects are sliding, then there's also a friction force. All right, so those are the surface forces. Those get their own little section in this course. Next up is tension. You can see this one as F sub T or just T. And I probably will bounce back and forth between those two. Tension, the symbol I use, honestly depends on how many ropes there are. And so this is a force that is due to something that functions like a rope. Anything that is rope-shaped and not stretchy, meaning it doesn't change its length very much. The tension force arises because when you like pull on a rope, you slightly stretch the bonds, and when you stretch a bond, it's longer than its natural length, and so actually like a spring, it pulls back to its unstretched length. The rule for the tension is it's always along the rope and away from the object at the end. And so we'll play a little bit with the tension force. It kind of, thinking about the tension force is often like a riddle. Next up, we have the spring force. Now, the spring force and the tension force are very similar. This is going to be Fs. And the spring force is reserved for stretchy objects. It has the same rules, kind of tension, and it's caused by the same reason. When you stretch an object, you stretch the bonds, and so they will pull back on themselves. The rule for spring force is always along the spring, and this time it's toward the spring's unstretched position. Now, springs are funny because the springs that we have in our classroom, they really just only stretch. They don't compress. But in reality, there's a ton of springs, including in your like pens, that are meant to compress. So if you just like lay a spring down on a table, it naturally gets to its unstretched position. And then if you push on the spring and make it shorter, the spring force pushes back on you. And if you pull on a spring to make it longer, the spring force pulls back on you. So that one gets its own section as well. Drag is the last one that has a specific set of rules, F sub D, and this is due to a fluid. Now, fluids is a unit in our course. It's the last unit of the course when we study basically like air and water and how they influence the physics that we've learned. Fluids cause this force because when objects move through air or liquid, they have to push the air or liquid out of the way. That's why if you swim, like you get a resistance. You have to keep kicking and to get forward. So fluids inhibit your motion. So the rule for drag is it always opposes the motion of an object. So drag is a tricky one because as an object travels through the fluid, if the object changes direction, the force of drag changes with it. It's always pointed in the exact opposite direction that it's going. That was a very long video, so thank you for making it through. There's one more. If you can't come up with a name of a force, because it doesn't fall into any of these 6 categories, you would call it an applied force. And it's just F, because you don't have a name for it. So any force not categorized. So basically, if you can't figure out what category it belongs to, it's probably because it doesn't belong to any of these categories, and we would call it an applied force. Applied forces are like, if I go push on this piece of paper, I apply a force to it. I am not a surface or a rope or a spring or a fluid, and so things like people and animals and cars exert applied forces on things. All right, so that's hopefully the longest video of this whole unit, where you have all these forces now in your notes, and next one we're going to work with those.